how do we solve x to the second power is equal to 2 to the x power? Well, you might first notice 4 to the second is 16, so it's 2 to the fourth. That means 4 is an answer. Yes. And of course, 2 to the 2 is equal to 2 to the 2 because both of them are equal to 4. So 2 is also an answer. Yes, but the main question is, can we have more answers? And the answer for that is yes. And to see that, let's just go ahead and take a look at the graphs. For y is equal to x squared, we will have a parabola, which looks like this. The graph for y is equal to 2 to the x is a exponential curve like this. And the exponential curve will overtake the parabola. So here is when x equals 2, and here is when x equals 4. And have a look right here. This is the third solution to this equation in the real world, that's all. We are not going to the complex world in this video. Let's see how we are going to find that. In fact, this is not easy because we will have to use the Lambert W function, but that's what makes this more fun. And if you want to get my written solution for this video, make sure you go download that in the attachment. Here we go. Let's start with x squared equals 2 to the x. I am just going to take the natural log on both sides. That way we can bring the exponents to the front. And then on the left hand side, we will have 2 times ln x. But remember, x could be negative. Instead of the natural log, that will be not good. Make sure we put an absolute value around it. That's the key. And then we will have x ln 2. And then I would like to just put all the variables on one side and all the x's on the other, all the numbers on the other. So let's divide both sides by 2 and divide both sides by x. So on the left hand side, we have 1 over x, which I will write it as next to the negative 1. And then on the right hand side, we have 1/2 ln 2. And for the 1/2, I'm going to put that up here to make that into an exponent. So that's like ln 2 to the 1/2 power, which becomes the square root. So I will just look at this equation as this. X to the negative 1 times ln absolute value of x equals ln of square root of 2. Now, what do we do next though? Well, let's see how we can take care of the absolute value. To do so, we can just break this down into cases. So for the first case, let's just say when x is positive, in that case, x in the absolute value is just going to be x. The absolute value doesn't matter. Secondly, if x is negative, then absolute value of x will give us not just x though, we will have to negate the x in order to get the positive result. So we get negative x. So for the first equation, right here will be x to the negative 1 times ln of just x. And that's equal to ln of square root of 2. On the right hand side for the second case, that's x to the negative 1 times ln, and the input is negative x, and then ln square root of 2. Now, what do we do with the first case though? Here's the deal. We have x to some power times natural log of x. Usually we want to take e so that e and ln cancel, but we do have one more thing that's multiplying with the ln. So if you take e to this whole thing, they are not going to cancel out nicely. This is where we can try to use the Lambert W function, and it will work in this case. So what's the Lambert W function? Well, let me put this down right here for you guys. The idea is that imagine if you have something in the front that's called a fish, right here, in front of e, and the e is raised to some power. And the key right here is that these two things, they have to be the same. So same fish. In this case, you can take the Lambert W function, just put a big W, and you will get the fish back, which is very nice. And this is really just like the same idea as if you have e to a single fish. In that case, you will just take ln, which is the natural log. Here, we will also get a fish back. But the natural log is only when e to a fish. The Lambert W function is that we have the same fish right in the front. Now let me write this down right here for you guys. This is called the Lambert W function. And if you want to enter this on WolframAlpha so you can get an approximation, this is called a product log, which is very similar to the name natural log, right? And the reason here we have the word product, it's because here's the multiplication, which is quite nice. Now, we want to get our expression to be in this form in order to be able to use the Lambert W function. Let's make that happen for the first case equation here. To do so, let's take a look at this x here. I'm going to force this to have base e. I'm just going to rewrite it as e to the ln x. That's fine, right? Because e and ln, they do cancel. And then, of course, we still have that raised to the -1 power. And let's put down the ln x in the front. And the right-hand side stays the same. Right here, let's multiply the exponents. Have a look. This is negative ln x. This is a different fish than this right here. But don't worry, because they are almost the same. All we need is multiply a negative throughout this equation. So we will be getting the same fish right in front. Negative ln x times e to the negative ln x. And that is equal to negative ln of square root of 2. This is where we can then take the Lambert W function, because this and that are the same now. And of course, we will do the same thing on the right-hand side. Okay, remember, once we take the Lambert W function, we'll just get a fish back, which is negative ln x. That's it. On the right-hand side, just keep it like that. The Lambert W function of negative ln square root of 2. Then we want to isolate the x. So do the usual business, divide both sides by negative. So we have ln x equals negative Lambert W function of the same input stays inside. And then we just have ln x. So we can do e to that power now. They cancel. And we have x being equal to e to the negative w of negative ln square root of 2. This will be an expression for the answer that we are going to get. Let's go ahead and do the same thing, but for case 2. Pretty much the same thing, same steps. Let's go ahead and rewrite this right here first, right? But before that, remember, I want to have what though? If I just put the x as e to the ln x, this is ln of negative x. So be really careful. I will actually have to look at this equation right here, right now, and then multiply by a negative first. So we will get negative x to the -1, ln of negative x, and then that's equal to negative ln square root of 2. Then we can look at the negative x right here, and then write that as e to the ln of negative x. This is how we can put the negative inside of the ln x. And of course, that part, you can just think about it like negative x to a -1. Think for the -1 to the -1 is still -1, so that parentheses, it still works. and we still have to take that to the negative power, and then let's put the ln of negative x in front. And then multiply the exponents. So this is how we can match the input of the ln. That's why we did that earlier. But now we have to make sure this matches with that. So we have to multiply by one more negative throughout this equation. So ladies and gentlemen, we will have negative ln of negative x times e to the negative ln of negative x, and that's equal to positive ln of square root of 2. And then finally, we see this matches with that, so we can go ahead and take the Lambert W function here and also here. And then on the left hand side, we will just have negative ln of negative x. And on the right hand side, just write that down. And then do the usual business then. Divide both sides by negative. And then do e to the power. So on the left hand side, we will have negative x. But I'm just going to be dividing negative on both sides. So I'll put a negative here. And then e to the negative w of ln of square root of 2. So as we can see, we have these two expressions for x. Now, if you enter these expressions on WolframAlpha with the Lambert W function being the product log, for the first expression, we will get 2. And for the second expression, we will get about negative 0.76666. And then the next one's 4, and then 6, and so on. And this is the negative answer that we were talking about right here. Yeah, that's it. But before we end the video, there's a small issue that we have to address. Because right here we have how many solutions? 1, 2, 3, right? But we only have 2 expressions. How can we get the 4, right? Well, here's the deal. If you look at the first expression where we have e to the negative w of negative ln of square root of 2. In fact, for the Lambert W function, it has different branches, and at different branch, it will give you a different answer. So technically, there is a subscript for the Lambert W function. So this is the technical part. Here, if you enter this on WolframAlpha, e to the negative w with the subscript 0, and the 0 is just like the principal branch. That's like the first answer. If you enter that on WolframAlpha, this will give you the 2. Earlier, when you didn't enter any number, by default, it gives you the principal branch value. Now, to get the 4, you will just enter negative 1 for the n for that. And then you get negative ln square root of 2 inside, and this will give you the 4. And to enter the Lambert W function on WolframAlpha, you do it like this. You are going to write it as the product log first, and then the n value, whatever that you want right here, and then put a comma, and then the expression that you want. That's how you do it on WolframAlpha. And just for fun, can you enter more different n values? Yes, and I will show you. What if you enter, let's say, 3? This is how you can actually get the complex numbers, and it will work. This right here, I'll just tell you, you will get approximately 11.79. That's just the real part, and then minus 58.35 I. I think this is really fun. And of course, you can also enter different branches for the second expression, but I will just leave that to you guys.